So we talked about how to find the formula for an ionic compound the shortcut way Friday, where we look up the charges and we cross them. Which charge always goes first?
Positive.
Positive, always goes first. Okay, that's how we write a proper chemical formula. All right, so now we're going to throw in transition metals because we've really been ignoring those. So where are the transition metals located? In the middle, which is the D block. So they're groups what? 3 through 12. So those are groups 3 through 12 metals. So we've been ignoring them because most of them can have multiple charges. So most have multiple charges. So because of that, when you go to find your chemical formula, you have to know which one it is that we're talking about. So it has to be given to you in some sort of way. So for right now, you're finding the chemical formula. So it's going to have to be given to you not in the chemical formula. Eventually, I'll give it to you like this, Cu(I)2, where you would have to know the charge of copper from the chemical formula. But right now, we're forming this, so we're not there yet. So right now, if I was talking about copper 2, I would just flat out have to tell you it's Cu+2. There's another way I could give it to you, and that's by doing copper Roman numeral 2. And that's the proper way to name it, is with a Roman numeral. And we'll get to that next unit when we talk about nomenclature. But here's the two ways I would give it to you right now. I would either tell you flat out, here's the charge. So that's the charge you're going to use to cross. Or I could give it to you in a Roman numeral. But they're all metals, so all transition metals are going to be a cation or an anion. Which one? Yes, so they're all cations. So they're all going to be positive. It's just I have to tell you what the charge is. So, for example, on your paper today, you might see something like so whereas before I might have just said barium and chlorine, and then you would have to find barium's charge and chlorine's charge and cross them. Now, do you need to go look on the periodic table for iron to find the charge? No, I gave it to you. That's because iron can be different charges. So I have to tell you in some way which one it is. So you're going to take iron, which is +3, and our positive still goes first. Then you take chlorine, and what's chlorine's charge?
-1.
-1. And then we'll just cross, just like we did before. So what's my formula going to be? Yep, FeCl3. So it's no different. It's just now I am going to be giving you those charges for those transition metals. Now there were 3 transition metals that we marked on our periodic table. Do you still have them marked?
Yeah.
Yep, so there was zinc, which was what? +2. There was silver, that was
+1.
and mercury.
+2.
So sometimes you won't see those given, and that's because they typically have a set charge. So sometimes I won't give you those charges, but like if it was a test and you forgot, you could be like, Miss Dow, what is zinc's charge? And I'd be like, +2. I'm not going to keep that information from you. So that's the only difference with the transition metals. I have to provide the charge. So when you get your assignment today, you'll go down here and you'll be able to tell which ones are transition metals because I already gave you the charge of them. So it's almost simpler than a regular metal because you don't have to go find it on the periodic table. What about do another example. Sn+4 and oxygen. All right, so which one is going to go first? Sn, so that's my +4. And then oxygen, what's oxygen's charge? -2. All right, so when I cross that, I get Sn2O4. Am I done? No, because what do I need to do? Simplify it. So what would that simplify down to? Yeah, I would divide both by 2. and I would get SN1, which I don't need to write the 1, and then O2. So I still reduce, I still cross charges, I still put positive first. The only difference now is that when you get one of these transition metals, you'll see the charge with it, because I have to identify which one it is that I'm talking about. Okay? Any questions about transition metals? Alright, so now let's move on to polyatomic ions. Now, some of you all, like if you've had me, you've seen these on the backs of the periodic tables that I give you for the test, and you've been like, when are we getting to that part? Well, today is the day. So, you have your periodic table. I'm going to come around and give you a clear sheet protector. I want you to put this on the back side of your periodic table in the clear sheet protector. Okay? So I'll give this out first. Actually, no, I'll give out this paper first. So, if you have the double-sided periodic table, I would keep this side and then put this on the back like this. These are the two that I'm going to reference. Okay? Alright, there you go. So put your periodic table so you can look at it on one side. On the other side are your polyatomic ions. Yes.
Josh doesn't know how to act properly. He's got a really bad attitude and some bad behavior. Tell him to adjust this down.
Alright, so I'm also going to post this in Classroom just in case you're at home and you don't have your sheet. So it's right up at the top by your periodic table. Okay, so these are not all of the polyatomic ions. There are a lot more. But these are the main ones that I'm going to use in class. And these are the ones that you're going to be quizzed on. But let's make that quiz next Friday. So you get plenty of time to study them. So you need to know the name and the formula. Name and formula. It's not that many considering there's a lot more polyatomic ions. But those are the main ones. So I want you to know those. Okay? Alright, so polyatomic ions. Let's break down the word. What does poly mean? Multiple. Alright, so this is multiple. What's the root word of atomic? Atoms. So multiple atoms. And what's an ion? It's an atom with a what? Charge. So multiple atoms with a charge. And that is the definition of a polyatomic ion. It's exactly what the word breaks down into. Multiple atoms with a charge. So now, instead of just one element with a charge, we can have a group of elements that all together have a charge. So I'm going to draw this out for you. You would not be required to draw this, not now. All right, but nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. And Ammonia is NH3, but ammonium, look at ammonium, the polyatomic ion. How many hydrogens does it have? 4. So I could attach one right here. Now hydrogen has 1 valence electron, so there's a bond. I could attach one right here, and I could attach one right here. Now this is a covalent bond, which we'll get to next week, but nitrogen now has 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's good. It's meeting the octet rule. Hydrogens all have their 2 they want. I don't have any room for that last hydrogen. This would be ammonia, which is in Cat P. It's in meth. It's that really strong odor. That's ammonia. But its close neighbor is ammonium. All right. Where can I put that last hydrogen? There's nowhere to add it. All right. So that's how we get a polyatomic ion. So if I was to add a plus charge here, what does that mean? Do I get to take away an electron or add one? Positive. Take away, right? Positive means I get to lose an electron. So I'm going to take this one out right there. And now I have one that's by itself. Can I tack on that 4th hydrogen now? Yep, there's my 4th hydrogen. So that's how a polyatomic ion works. Basically, I couldn't attach all the atoms if I wasn't taking out electrons or adding in electrons. So it's a group of atoms that has an overall charge because I'm either losing or gaining electrons within that structure. All right, that's a polyatomic ion. Now we're going to treat it like a group. A compound is still always made of 2 things. It's just now it could be made of a metal and a polyatomic ion, or it could be made of a polyatomic ion and a nonmetal, or it could be made of 2 polyatomic ions. Key thing is ionic compounds are always made of a cation and an anion. How many cations are polyatomic ions? How many are positive? Are you sure? Did you look at your list?
No.
Look at your list. Only 1, so there's only 1 cation, right? And that's ammonium. That's the only positive one. The rest of them are negative. All right? So the only positive one that you're going to see is ammonium. The rest are negative. All right? So let's do some practice. We're still crossing charges. Still doing that. That doesn't go away. We're still just finding chemical formulas. So let's say that we put together barium and nitrite. Barium and nitrite. Now, look at the ends of the polyatomic ions. Most of them end in ate or ite, which is much different than a lot of the elements. So if you see an ate or ite ending, it's probably a polyatomic ion.
What doesn't I mean look like?
Well, they don't look like nothing, it's just the name of it. But the difference between the polyatomic ions is the 8 endings have 1 extra oxygen. So when we get to the nomenclature, I'll teach you that they ate an extra oxygen. That's how you can remember that the 8s have 1 more oxygen than the 8 endings. All right, so we first just look them up. All right, what's barium?
The recording. It stopped.
No, it didn't start. It just said low
Low
power.
battery.
Oh,
It's on 20.
is it still recording though? Okay, cool. Well, yeah, it probably wasn't much charged than that. All right, so what's barium? Symbol and charge.
Is it the
+3 and the symbol's B.
Are you sure it's +3? That's boron.
Is it the BA plus 2?
Yes, barium is Ba +2, so we know that one's gonna go first. Now I have nitrite. So what's the chemical formula for nitrite?
NO2 negative.
NO2. And if there's no number, what does that mean? 1. Scientists are lazy. We don't write ones. We don't write them as subscripts. We don't write them as charges, but you can. So -1. All right, I'm still going to cross my charges. All right, so my 1 comes over here. But now, when I bring my 2 over, I don't want it to look like 22 oxygens. I want 2 nitrite groups. So this is where our parentheses come in. So I parenthesis nitrite, and I put my 2 outside.
And what does
Wait,
that
what?
mean?
So now I rewrite it, and I have barium. Do I need to write the 1 subscript?
No.
No. Parentheses, NO2 with the 2 outside. Have you seen chemical formulas written with parentheses before? That's how you get them.
And what does that mean?
Switch them?
barium nitrite.
That's it.
That's literally it. Yep. There would be 2 nitrite groups for 1 barium.
Is that in anything?
Not that I know. It dissolves in water because all nitrites and nitrates dissolve in water, but that's about all I know.
Medicine or something?
Missed
Like,
Can you
Yeah.
use another example?
Yeah. All right, let's do ammonium and phosphorus. Ammonium and phosphorus.
So you said we have to like memorize these?
Yep, but I'm giving you 2 weeks. Make some flashcards. We used to make you do 50 element. You had to remember 50 elements quizzes. So I feel like a few polyatomic ions isn't bad. All right, so ammonium. What's ammonium?
NA4 plus 1.
Plus 1. All right, and what's phosphorus?
P.
-3. So I have my positive first, my negative second. Do I need to worry about crossing my 1? No, because I'm not going to write it anyways. But when I bring my 3 over, I don't want it to show 43 hydrogen. So what do I need to do to ammonium? Parentheses it. And my 3 would be outside. So my formula would be parentheses NH4 with the 3 outside and then the P. So NH4, 3P. So I'm still putting positive first, negative second. I'm still crossing charges, but if I cross a charge over a polyatomic ion, I want it to apply to the whole group because now, does this 3 also apply to nitrogen? Yes. If I didn't have the parentheses there, would it apply to nitrogen? No. So I need it to apply to the whole thing, which is why I put the parentheses.
Wait, where'd you get the 3 from?
It's the charge of phosphorus. All right, let's do some more examples. Oh, do you have a question? It's the charge of ammonium because if it's just a positive and if there's no number, it means 1. Yeah. All right, so the first one up here, barium and fluorine. So you do it. Barium and fluorine. Do the first one.
This is one of the ones that we've done before. Probably, yeah. Because it gave it.
All right, so what's barium's symbol and charge? All right, what's fluorine's? So I have Ba plus 2, F minus 1. So when I cross that, what's my formula going to be? BaF2. All right, do the second one. Nitrogen and aluminum. All right, what's nitrogen symbol and charge? -3. -3, and aluminum, Al +3. So which one's gonna go first? Aluminum. And what's gonna happen to my 3s?
Cancel out.
They're gonna cancel out. So I'm just gonna have ALN. ALN. Alright, do the next one. Alright, well we know iron is +3 here, and that's Fe. What's phosphorus? P what? -3. So what's gonna happen to my 3s again? Cancel out. So I just get FeP. FeP. Alright, do the next one. Lithium and sulfate. Not sulfur. Sulfate. Alright, so what is lithium symbol in charge? +1. And sulfate is SO4 -2. Alright, so I have Li +1, SO4 -2. Do I need to cross the 1? No, because I'm not going to write it. So when I cross my 2, it comes down over here. So Li2, SO4. Do I need to put parentheses around sulfate if I'm not adding a subscript over here? No, it's not wrong if you do, but you don't have to because you're not adding anything. You're not putting multiple groups over there. So you don't have to, but it's not wrong if you do. All right, finish up the last 2 of them, and then we'll do those on the board. Yes, Mia.
For number 6, which one are we using?
It's up to you. I think that the C2H3O2 is easier. The reason why it can also be CH3COO is because that's what it looks like. So I think that it's easier to just remember C2H3O2 than that. So. Alright, check your answers on those last 2. Yep.
Could we put the PO in a parenthesis?
Now, can I reduce either of these?
Well, we can do two.
The only way I could reduce it is if I had a 2 right here. So the only numbers you're looking at is copper subscript and acetate subscript. So if I had a 2 here and a 2 here, I could make it 1 and 1. But I can never change any part of what's in my parentheses, because then I'm changing the chemical formula of the polyatomic ion, and then it's not that polyatomic ion. Alright, so if I had this in parentheses with a 6, I could reduce the 3 and the 6, but you can never reduce down what's inside of your parentheses. That has to stay the same. So only the numbers that you're crossing can reduce. Okay? Alright, so for your assignment, I don't remember writing all this. Alright, well, first of all, flame test. Tomorrow we're going to do the flame test, which involves, what do you think? Fire. Alright, so for that reason, make sure you have on either short sleeves or something that you can pull up above your elbows. So make sure it's not too tight to where you can't pull it above your elbows. Alright, because I don't want anything from your elbow to your wrist, clothing wise. Okay? Because we don't want that to catch on fire, because you're going to be sticking stuff in fire. Long hair, which means it touches your shoulders, needs to be pulled back with something. So bring hair ties, because all I have are rubber bands. Alright? And if you're still missing your syllabus or lab safety contract, you're going to score a 0 for the lab tomorrow, because you can't do it. So you have to bring that in by tomorrow. Okay? Alright, so your worksheet is this paper. It's all ionic formulas. They're all mixed together, kind of like the review we just did. Look up charges, cross them. Which charge always goes first? Positive. So if I didn't write it that way, you flip it and write it positive first. Okay?